welcome back. Hello. Give me one more moment as I get myself coordinated. Nope, this way, that way. Yep, sorry. I always start from scratch. Always and forever. There we go, getting it. Okay. So, we are still working with fractions. This is part 4. In this particular section, we're going to work on simplifying fractions. Yes, indeedy. So, the idea of simplifying fractions is taking one particular fraction, let's say 3/6, and reducing that to an equivalent fraction, which 3/6 reduces to 1/2. And this is done in the same way that we were looking for the greatest common factor to change fractions. Because as you see, if you have a circle with 6 pieces and a circle with 2 pieces, and you color in 3 of these pieces, 3/6, or 1/2, it is the same shaded region. Same, assuming these circles are equal, the shaded region would be the same. Excuse me. So, that is to say, if we have another example, such as 6/9, which 6 and 9, we have a circle. Oh, I say a square would be easier to demonstrate. So then we have this rectangle. It has 9 pieces. Roughly 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6 of those are shaded in. It's like, okay, 6/9, I can get behind that. That makes sense. Which is shown to be equivalent to 4/6. It was really odd. Sorry. Oh, geez. Okay. So first of all, I can't draw things equivalently. I'm just really, really bad at it. So 4/6, 1, 2, 3, 4/6. This should honestly be lining up here. I can't tell you how much I wish I could draw nice and evenly, but alas. So I will have to show you numerically why that one's the same. And then we get 2/3, which should all be the same. So the reason why 6/9 is equal to 4/6 and 2/3 is because, and we've done this, we have found the least common or greatest common factor and the prime factorization of numbers. If we do the prime factorization of 6, that is 2 times 3. And that's it. That's all we have. And then 9, we have 3 times 3. And this is still over under numerator denominator. But fractions are a very fancy type of dividing, because 6 divided by 9 is the same thing as 6/9. So that means 2 times 3 divided by 3 times 3. And because we can do multiplication and division at the same time, this is why we can reduce or simplify fractions. We can look at and see if they have anything in common. We both have a 3. So if we were to isolate this, we would see 3/3 equals 1. So it would just be 1 with 2 over 3. All right. So this leads to the rule, if you have numbers in the numerator and numbers in the denominator, and they're multiplying, this is the same as taking it apart and multiplying those individual fractions. It seems like quite a jump, but yes, you can do this. And that way you can reduce pieces that look alike. 3 and 3 is just 1, so you're remaining with 2/3. But how do we get to 4/6? Well, 4/6 operates in the same way. So we get 4 over 6, and 4 is 2 times 2. 6 is 2 times 3. We have these pair of 2's. That is just 1. So then we are left with 2/3. So a fun little test you can do here is finding what is called the cross product. A cross product is if some fraction, let's say 2/3, is equal to 6/9. The cross product to test here is you multiply the 2 and the 9 and the 3 and the 6, and if these multiplications, are the same, then these fractions are the same. So 3 times 6 is 18, as is 2 times 9, which is also 18. That is just another way to check. So for an example, we have not enough space. We have 3/8 and 9/24. Are they the same? So we have 3/8 equal to 9/24. Suppose they're equal. We're assume. So 3 times 24. 8 times 9. 3 times 2 is 60. 3 times 4 is 12. 60 plus 12 is 72. And 8 times 9 is 72. So they are, in fact, equivalent. So here we have another example. Is 7/8 equivalent to 8/9? It doesn't feel like it is, but we have to prove it. We don't discount the feeling, but we have to prove why it is correct. There we are. So 7 times 9, 63. 8 times 8 is 64. So not quite. They are not equal. Cool. Okay. So moving forward, to simplify a fraction reduces a fraction to lower terms, means to find the equivalent fraction with the smaller or smallest numerator and denominator than that of the original fraction. So what that means here, I can get it to focus. There we go. Maybe I'm too close. So we have an example. We're given 5 over 15, and simplifying a fraction, or reducing a fraction. 5 over 15 is a proper fraction. We can work with this, but it can be reduced because we see somehow, some way, 5 and 15 have some factors in common. That is to say, 5, sorry, didn't mean to. 5, the prime factorization of 5 is 5, and 15 is 5 times 3. Now, if you see that 5 and 5 are in common, but there's nothing left, there is always, 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 always a 1 there. Because 5 is 5 times 1. And technically down here we also have a 1. But if they canceled out, we would still have a 1, because 1 times 1 is 1. You can always find a 1. So, if we take the 5 out, we are left with a 1 in the numerator and a 3 times 1 in the denominator, which is 3. This is my recommendation going forward, is to find the prime factorization of your numbers and take out what is in common. So we have another example of 4 over 8, wherein 4 is 2 times 2, 8 is 2 times 2 times 2. So 2 and 2, we're left with nothing but a 1 over the 2. Now, before we move on, we just learned how to check this. So to check your answer, we have 5 over 15 equal to 1/3. Cross multiply. So we have 5 times 3, which is 15, which is the same as 15 times 1. And for here we have 4 over 8 and 1/2. 4 times 2 is 8. 8 times 1 is 8. So we have some pretty simple examples, arguably, compared to what you may have going forward. One more example here, or another pair of examples. We have 30 over 45. So 30 is 3 times 10, and 10 is 2 times 5. 45 is 5 times 9, and 9 is 3 times 3. So we have the 5 and the 3, but we're left with this 2 and the 3. And so to check, we have 30 over 45 equals 2 over 3. 3 times 30 is 90, and 2 times 45 is also 90. Now, using the same fraction, the 30 over 45, we have a question that asks, write 2 fractions that are equivalent to 30 over 45. We found that 2/3 is 1, but how would we find another? We would, since we've taken out common factors, we'll put in common factors. And because any number over itself, so 2 over 2, 5 over 5, 100 over 100, they all equal 1, we can simply multiply this by 1, or any choice of 2 over 2, 3 over 3, 4 over 4, 5 over 5, a million over a million, whatever really you want to pick in this case, because the question was vague. I am going to pick 3 over 3 and just 3 over 3. not the 3 or 3 and 5 and 5. Because we've had that, and that comes back to what we were given, which is technically true, but I'm pretty sure your teacher would not see it that way. So we picked 3 over 3, 2 times 3, because if you multiply straight across, because we had just depicted that multiplying division is also dividing the multiplication, so 2 times 3 over 3 times 3, so you get 6 over 9. So that would be another equivalent fraction. Now, there could be a way. There's another way, and it depends on how you want to approach it. We've been using the prime factorization to reduce a fraction. But if we were given a different approach with another fraction, 42, we see that 24 and 42 are kind of both divisible by 2. So 24 divided by 2 is 12. 42 divided by 2 is 21. And then we see they're both divisible by 3. This is the kind of touchy-feely dividing. We don't have to factor out, but we do have to divide over and over and over until we get to somewhere we're going. So again, we see that they're both divisible by 3. 12 divided by 3 is 4. 21 divided by 3 is 7. 4 and 7 have nothing in common, so that simply reduces to 4/7. And, as always, cross-multiply to check your answer. So then 7 times 24 is 7 times 20 is 140. 4 times 7 is 28. 168. And 42 times 4 is 168. Yep. Et voila. So, we're going to apply this method again, just to kind of give an example, give another feel for it. If we're given the fraction 60 over 75, they're both divisible by 5. 5 can fit into 60 12 times. 75, 1 and 3 times. And that's all they have in common, really. So 12 and 13. Check back. So 13 times 60, which would be 6 times 13 times 10. So that'd be 60, 78, 780, and 75. If you need to, you can write it over here. I need to, so that's why I'm gonna. So we get 750 plus 150. 5 and 5 is 10. It's 90. That it must have been when I put this wrong. That's why we check our answers, folks. We are often more wrong than we let on. So again, 13 times 60 is 6 times 3 is 8. Carry the 1. Oh, I'm silly. I didn't divide right. So I see why it's not coming out right, because this isn't correct. 75 divided by 5. Put into there once, 25. That is a 5. Not 12 over 13, but 12 over 15. Haha. So 12 over 15, which can reduce. Just go back through here. Good enough. So 12 over 15. 12 and 15 have a 3 in common. You can reduce further, which 12 divided by 3 is 4. 15 divided by 3 is 5. So 4 and 5 have nothing together but 1. So we have 4/5. And now, when we check, we should get something more equivalent. So 60 times 5 is 300. And 4 times 75 is 2 times 150, which is also 300. Alrighty. Well, that was a rough example. Let's try a nicer one. $84 divided by 196. So 84 and 96, I feel I don't know. They might have a 7 in common. But why I guess this is because I know that 196 is 14 squared. And if this is 14 squared, 84 is divisible by 7. So I'm just going to roll with it. So we're going to take a 7 out of both. 84 divided by 7 is 12. 196 divided by 7. Can fit into there twice. 56. Oh, look, it does. 28. 12 and 28 have a 4 in common, so you get a 3 and a 7. And 3 and 7 have nothing else in common but a 1. So that would be your reduced fraction. Check your answers with 84 over 196 equal to 3 over 7. 84 times 7 and be 28. Carry the 2, 56, 57, 58. And then 196 times 3 is 300 plus 270 plus 18, which would be 8, 8, and 5, which are the same. So yes, that reduced fraction would be 3/7. As we have gone over most of finding common factors, reducing fractions is pretty straightforward. Once you are able to find common factors, you can reduce fractions very easily. So we are going to jump into the examples. As there are 56 examples, let's just do every third one, starting with 1. I'm going to scoot you back just a wee bit. Keep things from getting too blurry. I say as I make it more blurry. There we go. So number 1, are the pairs of fractions equivalent? So number 1, they provide 1/3 and 3/5. And we check this with cross multiplication. 1 times 5 is 5. And 3 times 3 is 9. So no, they are not equivalent. Exercise 4. We have 2/3 and 3/5. So 2 times 5 is 10, but 3 and 3 is still 9, so no, they are not equivalent. We have 2 and 21, 4 and 25. So 2 and 25 is 50. 2 and 25 is 50, but 4 times 21 is 84. Man. Excuse me one moment. So, no, they are not equivalent. Next one. We have 12 and 15. These aren't equal, they were just provided. We have 12, 15, and 36. 45. So then 12 and 45 is 450 plus 90. It is 540. And 15 times 36 is 360 plus 150 plus 8, plus 30. 6 plus 5 plus 3 is 14. Carry the 1. 1, 2, 3, 4, 5. As they are both 540, yes, they are equivalent. "13" is a word problem, so 1 moment. So, on a test of 72 questions, Sam answered 54 correctly. On another test, Sam answered 66 correctly out of 88. And did Sam get the same portion of each correct? So this is just we answered 54 correct out of 72, if I can write it nicely. And he answered 66 correct out of 88. Are they equivalent? So we cross multiply 54 times 88 from right to left. 8 and 4, 32, 8 and 5. That is 2, 5, 7, 4. 54 and 88, so we get the 72 and 66. And we get 2, 5, 7, 4. So they are the same. Yes, they are equivalent. Did Sam get the same portion of each test correct? Yes. So, in question 16 onward, it says to write each fraction in simplest form. Number 16, we are provided with 12 over 15. And I will alternate between approaches. So I'll try to show examples of the use of each approach, either factoring or dividing each number by something they may have in common. So this one will factor. 12 is 2 and 6. 6 is 2 and 3. 15 is 3 and 5. So 2 times 2 is 4 over 5. Check your answer. We will check the first two, but you should always check your answers. Always, always, always. So 12 times 5 is 60, as is 15 times 4 is 60. We are given 12 over 18. 12 and 18 both have a 2 in common, or excuse me, a 3 in common. Well, if they have a 2 and a 3 in common, they have a 6 in common, right? So 12 divided by 6 is 2. 18 divided by 6 is 3. And that's all we got. So that is the same as 2/3. Checking our answer, 12 times 3 is 36, as is 18 times 2. We're given 21 over 24, which factor out to 3 times 7 over 3 times 8. 8 is 2 times 4. 4 times 2 times 2. All we have is the 3 in common, so that is the equivalent of 7 divided by 2 times 2 times 2 is 8. Okay. Something to quickly note here, I can identify that 36 is 12 times 3. So we can take a 12 out of both of these. So that's a 1 and a 3. So factoring these, we have 3 times 10, which is 2 times 5. We also have 5 times 10, which is 2 times 5. And the 2 and the 5s are common, leaving the 3/5. $75 over 105. They both seem to have a 5 in common. 5 taken out of 75 is 15. 5 out of 105 is 21. 15 and 21 have a 3 in common, so that's a 5 over 7. 5 and 7 have nothing together but 1, so that would be the same as 5/7. This would be factoring. So 48 is 4 times 12. 4 is 2 by 2. 12 is 2 by 6. 6 is 2 by 3. Bottom is 6 times 11. 11 is prime. And 6 is 2 times 3. So we have the 3 and the 2's in common. So what we have left is 11. And 2 times 2 is 4 times 2 is 8. Oh, impressive. All right. And through feel and divide, I feel like these two have 11 in common. 11 from 66 is 6. 11 from 110 is 10. These two have a 2 in common, so that'd be 3 and a 5, and that is all we can do. So that'd be 3 fifths. All right. From factoring, 21 is 3 times 7. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. We have nothing in common. So this is the simplest form that fraction is in. All right, so moving on, we have number 43, which asks, a quarter is what fraction? Of $1. And don't forget to reduce your answer, as that is the point of this lesson. So a quarter is 25 cents, and $1 is 100 cents. We have 25 over 100. If you wanted to factor that, that is 5 times 5 over 10 times 10, which is 2 times 5 times 2 times 5. These 5's would cancel out. You're left with a 1 over 2 times 2, which is 4. So 1 quarter is, in fact, 1 quarter. So what fractional part of a day is 8 hours? Simplify your result. We are given 8 hours. We should know there are 24 hours in a day. So 8 hours out of 24 hours in a day reduces to, they both have an 8 in common, and that's lovely. So from 8 is 1, from 24 is 3. So 8 hours a day is 1/3 of a day. $49. This is a lengthy word problem, so one moment, please. So Susan did a tune-up on her car. She found that 2 of her 8 spark plugs were fouled. What fraction represents the number of fouled plugs? Reduce your answer. So, as we were given 2 of her 8 spark plugs were fouled, this reduces to 1 over 4. Yes, so that would be 1/4 of her spark plugs were fouled. It took longer to write this problem than it did to solve it. Just pointing that out there. Just pointing that out. Speaking of another lengthy problem, all right, so Sharon earned $250 at her after-school job. A new bike cost $120. What fractional part of her money will remain after she purchases the bike? So remains after. So 250 minus 120 is $130 remaining. So the fractional part of this, with $130 remaining from her 250 earned, which would be, I get the gist that both of these are divisible by 10, so that would be 13 over 25. This does not reduce, so this is your fractional part. I believe we have we will check. Last problem before we'll sign off for today. So this is a relatively short section. So we have number 4. The question asks, can any of the following fractions be simplified? So we're given part A, 824, divided by, or 824 70 thirds. Well, I don't inherently see anything here, but we can go through, starting with 73. It's divisible by 1, as all numbers are. All whole numbers. We'll go with that for right now. Not divisible by 2. not divisible by 3, not divisible by 4, or 5, or 6. But is it divisible by 7? Well, let us try. 7 can fit into 7 once. Drop the 3. It cannot, and there'd be a remainder. Doesn't matter what the remainder is. If there is a remainder, it is not divisible by. So it's not divisible by 7, or 8, or 9, or 10, or 11, not 12, maybe 13. So let's try 13. Oh, bother. So multiply by, I'm going to guess, well, if it's not divisible, if it is divisible by 13, then the answer here would have to be less than 7, and we know it's not divisible by 7 or anything less than that. So it's not divisible by 13. I'm willing to assume that this is not divisible by any number other than 73 in itself. So, must guess if 824 is divisible by 73. If we can fit 73 into 82 once, so 12 minus 3 is 9 and 4. 73 can fit into 94, which would leave us with 21, which would be a remainder. So no, cannot be simplified. Part B, we have 59 over 11. And as 11 is prime, it cannot be factored, it cannot be reduced. And 59 divided by 11 is 5 with a remainder. So no, it cannot be reduced. Last problem is C. 135 divided by 17. 17 is prime because nothing can be factored out of it. So we can only hope that 135 divided by 7. So 17 cannot fit into 13, but 135. I'm going to guess 6 times, and that may be too small or incorrect. So that's 60, 102. It can go in a couple more times. Maybe one more. So 7 times 17 is 70 plus 49, which would be 130. Now, 70 plus 49 is 119. I guess it would be one more. I'm sorry. So 17 times 8, which would be 80 and 56. So that would be 136. No, 7 was close, but it would have left a remainder. So no, this does not reduce. Alrighty. I believe that is the end of simplifying fractions. And coming in the next video, we will in fact be multiplying fractions. Finally, the whole time, we're getting there. In that case, any questions, comments, concerns, I will address as they come. Thank you.